Hi, good morning. My name is Lav Kumar. I have 4 years of experience in data science and AI. So today we go through about the large language models. Now everyone talking about the large language models nowadays. People are using ChatGPT, Grok, Gemini AI, like anything. So, but every time we have struggled to run the large language models by having the API keys only. But why don't we? There is the Ollama is there. That is the one of the orchestra and will give you the access to run all the LLM models in your local. So in general case, you have to purchase the API key, then only you can access and you can run your code. But in your local machine, are not able to run because the large language models are the size of the parameters are very high. So, but Ollama will give you the access. This is the one of the orchestra. So today we will go through the large language models, how to run it in your local by using Ollama, by using the without rag and as well as the with rag. We will try to understand why uh, the rag system will getting existed. Okay, I will try to explain the each and every part so clearly. Okay, so Olama is the one of the orchestra. Of course, there are the another orchestras also there, like Live Kit is there. Sorry, there are the Lang graph is there, Lang chain is there. Okay, Llama index is there. Okay, but still they need the API keys. But here you don't need to require anything. So let's say if I open here, so this is the Ollama GitHub. So from here you can download it for if you are using the user of Mac OS, you can download it from here. If you are the Windows user, you can download it from here. Okay. So I am the Windows user, so I have downloaded the Windows from here. Then I am using the Ollama here now, right? So for that, you just install it and you just pull out the model. So here all the instructions already there for the based on your OS. So here I'm using the GPT 3.1. So you just need to, after installing, you need to run this command. Then you can easily run the different models. Here they provide the different models, right? So how they are really giving the running the models in your local, how it's possible is because the parameters are very low. So that is the way based on your system size also you can choose the models. Here I am selecting the GPT-3 models because the parameters are very low and in my system it can easily run. So that's why I'm pulling the same model. So this is the way you can pull the model by using you can use the command prompt here, or otherwise you can use the git bash. So you can just pull it, this model, and then you can run in your VS Code very easily. Okay, so you can follow the documentation. So after that, you just need to install the Ollama here. Okay, so after installing the Ollama, then what I do is, so I'm trying to connect with the LLM and by asking the some questions regarding the some general questions. So how it is answering also we will check. So for that I'm installing the libraries. So from Ollama I'm installing the chart. This is the and from Ollama I'm importing the chart response also because I need to get I'm giving the taking the model to run the model. I need to use this the chart one. Okay, then and for getting the response I generally use this. Okay, the Ollama will provide you these two libraries to run the model, and as well as the you need to get the response. Okay, so for that I just created the chat response. Okay, here I am calling the GPT 3.1 billion model, and also I am giving them the user, and here I am asking the some question, the prompt I have given the here. What is the, so why is the sky blue? This is the one prompt I have given here. Okay. So what this prompt will do, one sec guys, I just move this one to down. Yes. Yeah. So asking this question, and I'm getting the response, the manner of response dot message dot content. So from this, it will give you the complete response to you. So whatever the way you want, that response will comes. So let's see how the response would be. So I run this. So I have already run all the cells. Okay. So yeah, let me erase all these things. So here I got the response, and it will explain the why really the sky is blue, what exactly the reason. So maybe there are the different colors are there, different of course sunlight have the different colors because of all the combination of the colors from the earth. It's look like the different colors at the different timings. So it is clearly explained, and it is bring us the some resources also. It's really fantastic, right? So GPT 3.1 did the fantastic job here. And also I'm trying to ask the, let's say you guys can ask some question, the similar question. And here we don't have the chance to every time you are deleting this and giving the prompt. So just I'm want to give the input to ask the whatever the question I have. So that's why what I do is just I'm giving the user prompt input. So from here, I will ask the different questions. So based on that, I will get the answer. So here also is the same. The chart will take the all the models. So the models, this is the model I have. So and the prompt I'm asking from here. So this user prompt will come to here, and then this response is already there. This response, the chart will run, and the message completed, the complete message. The complete message will goes to the model itself. So this model will give you the output over here. Okay, so and it will print the output. So if you check it over here, so the output is looking like this. I'm asking the, this is the one of the question I'm asking, who is the president of USA, and it is giving the November 2 based on the 2023. The response is like not updated, but it is giving the response because it is trying till that time. That's why it is giving the Joe Biden. But now the US president is the, of course, Trump, right? So it is giving the some links also. So there is a disadvantage along with this calling the model directly, right? So I can't ask the updated information, and also it is failed to give the response regarding that. That is the major issue with the calling the model directly, right? If you take the any other models also, Llama 3 model or Grok model, or so if you take the any Queen, DeepSeek, any kind of model, what exactly happen here is they have the some knowledge cut, that they have trained till that time they will respond for that particular data only, right? Only for the train data. Otherwise, it is giving the wrong answers. The hallucination will be happen. So if I ask the some customized regarding any company or anything related to any specific information questions, if I ask the any questions regarding the any particular part, it will give the wrong answers and it will hallucinate, right? So the LLM's hallucination we can reduce by using RAG. So the RAG system is the retrieval augmentation. So this is the one of the finest method. For there are different methods are there, but RAG is the one of the system will help you to give the you can customize the documents. If you have the all the information in the document wise, you we can take that and we can use that, right? So whenever you are particularly looking for the ask the questions regarding the any particular system, you just need to use the RAG. Okay. So the retrieval augmented system will help you a lot. But before going to this, we need to understand the flow, right? So RAG is the particular system. It have its own flow. So the flow like this way. Okay, so here I'm trying to explain each and every part why it is existing, how this flow is going on, and how exactly it is really give the correct answers for the your customized data. If you have the your company data, if you have the your own PDF or own textbook or own any CSV files or one company data in the CSV format or Word format, you can upload the data and you can ask the questions, right? That facility is there. So that is facilitated by the RAG. So here again I'm using um, the Ollama only. Okay. So before going to that, let me explain how exactly the RAG will work and what are the different components are there and why it is existing. So how the RAG is working is I can make the comparison with the human body. So let's say if you want to eat a watermelon without making any cuttings, if you are eating directly, is that possible? You are not an elephant, right? Yeah. So let's say if you are eating the complete the largest or smallest watermelon, you can't digest, right? So for that, what you have to do? You just need to do the cuttings by make the you have to take the knife and you just make the uh, equal parts or different size of parts, and then you can eat small pieces. Then the digestion system will make the digestion properly and you will get the energy, right? So you get the output, proper output, and you will get the ultimate goal is the you need to get the energy, right? So the similar fashion, the RAG also do. Let's say if you are uploading the 1 GB of the any PDF or PPT or any documents or any files. Let's say I'm giving the per se. So if you are uploading the large scale of the data also fine. But here, if you are uploading that much data, if you are giving the directly to the LLM, what happen is it will definitely will give you the hallucination and sometimes the wrong answers may be. So for that, we need some systems right here. So for that, so here you are the user. So the user is giving the he is asking some question. Let's say here I'm asking the who is the president of yes, or otherwise what are the recent so when will be the Olympics will be may happen, you can ask such questions, right? So you can ask the prompt over here. So you can ask the any prompt over here, right? So what happened here is, let me rub this. The color is not really. Yeah, I'm taking this one. Yeah. So so here you're asking some prompt for the question. What exactly happened here is the user query, whatever the query is there, the query will goes to the embedding model. Okay. And so here the query is converted into embedding segment. So before this, we should upload the whatever the files you want to make the queries, you should upload them. And so I'm explaining the watermelon example. So that's why you are making the complete whatever the file is there. You just need to make the chunking over here. So again, what is this chunking? Cutting the parts. That's it. You have the large file and you're making the pieces, right? So the chunking like a dividing the large text into small documents, right? The documents will divided over here and sending into the embedding model. Again, here also one of the model will work for you. What exactly this embedding model will do? So why it is required? So the large language models don't understand the your direct text or your direct language, whatever the English or Hindi, whatever the Telugu or any language it don't understand. To understand only the machine language, it is in the form of the vectors. So the conversion will be happen here, the embedding models. Okay, there are a lot of models out there. So here the first what happen is first you are uploading your document and the large document will be converted into small chunks. So each part you can call it as the chunk over here. This is the chunk one. This is the chunk two. Okay, so the chunk three. So this is the way it is getting divided, and again it is sending to the vector store. So why you are saying that embedding model already converted your chunks into vectors, but why this vector store? Because you have the lot of vectors and you need to store it somewhere only. It's like a library. You can say library. In your library, you have a lot of books are there, right? Lot of books are there, right? So the books are like how they're storing. They're putting let me so this is like a book library. You have a lot of books are there, right? So here what exactly happened here is different embeddings are there. So these embeddings are stored here, not in the normal fashion. How a library have the different department books are there, like say physics books are located somewhere and the computer department books are located somewhere, and you can take the chemistry or the MBA books. So the separate departments will have the different books. How in the similar fashion, the similar kind of data will store at the same place. It will like this this is the one way. So this is belongs to these all are looking like this similar fashion. These all are looking, they have the similar characteristics. These all are have the similar characteristics. If you know the KNN is the one of the machine learning algorithm. So how it will have store the data? So how it will differentiate the data points like who have the similar character, how it will store. So the similar fashion, the cosine similarity is the one of the technique we are using here. So what exactly happened here? You have the all the vectors. Let's say there are the two vectors are there. So let's say here the data is regarding the movies. Let's say so the movies are like Iron Man is there, or so yeah, 1 second. Let's say yeah. So this is the one. So here I'm putting the Iron Man and the Avengers. Different movies are there. So if you want to find the similarity between these two, they are the fictional movies, right? They are the fictional movies. So that's why they have the distance and the angles are similar. And by using this technique, what we do is we will store these two movies are the similar kind of movies at the same location. Okay, the location is looking like this. So all the movies are stored here. Okay, the sci-fi movies. And if you have any action movies are stored here. So why we are storing like this? So when the augmentation will be happen, when the retrieval will be happen from this vector store, we can easily retrieve the data. Right? Let's say I want to take the one chemistry book from the library. What I do is I will just enter into the library and I will take that, go for the chemistry department, right? Let's say you can take the computer department. In the computer department, there are the different books are there. Let's say I want to take the Python notebook. So just I will enter over here and I will find the particular whatever the book I am looking for. I can take it, right? So this similar fashion, the retrieval process can easily happen by using this vector store. That's why for the large systems, what I do is for large documents, I will make the chunks and converting into vectors, and I'm storing all the vectors in the by using similarity technique. I'm storing it, right? So here the complete system how it will work is so here we need to mention the prompt also. The how exactly this flow will be happen. Let me explain clearly. Then the coding implementation also the process is the so similar. Okay, let me rub all of these things. Yes. So so the flow will be happen. First of all, you just need to whatever the document you want to make the question and answering, you need to take that. Okay. You just need to upload. After uploading, it will extract all the text. Okay. Here extraction procedure will be happen and then all the chunkings will be happen. Okay. And all the chunks will be again converted into so you have the different chunks already there. So all the chunks will be converted into vectors here. The all the vectors. These are like 0, 1, 0, 1, 1. And this is another vector 1, 0, 1. Like this. Okay. So the vectors again here by using similarity technique, it will store over here. Okay. So the complete document now stored over here. Let's say this is the one of the PDF regarding the something like rag. So here now user is coming to here and he is asking about some question what is meant by rag. What is meant by retrieval augment system? The query will be sending to the embedding model again. Here why we are sending to here because this is also in the text format. So LLM don't understand this. So that's why I need to convert this one into embeddings. And now this is like a person. It will be sending inside the vector database and looking for the particular whatever the user asking the query. So it will try to make the similarity search, which is the more similar to the this rag. So the question will be trying to make the, so already here the lot of vectors are there, trying to make the match. And now it will try to bring the relevant documents. So it will be in the form of already vectors, and it will bring the all the documents, all the context coming out of here. So again, so whatever the context come out of from here, the again we will have the prompt and the query. So we will create the prompt like whatever the way you need to get the output, and what exactly the way don't hallucinate. We will give the some prompts. So we can give the external prompts over here. Okay. The prompt and the query. So the query plus the prompt and the whatever the context we are getting from here, we are sending to the LLM here. Okay, here it will understand like the whatever the requirement, the what exactly the query and the prompt, what exactly the requirement you have given. It is like a string format, JSON format, whatever the question you're asking. Okay, whatever the instructions we have mentioned inside the prompt, and based on these two, the query and prompt, it will generate the output, and that is only the thing will be visible over here. So if you take the chat gpt, if you are asking the query, how it is directly giving the answer. So the based on your prompt only, it is giving the response, right? So let's say if you go for the Gemini AI and you're asking for the creating an image, how it is creating? It is again go for the database, and it is bringing the output. It is creating the proper image, whatever the way you're asking, the whatever your instructions you have mentioned, right? So these instructions are very important. So the prompts are very important. So based on that prompt only, it will give you the output. So let's try to understand from the by using Ollama how this rack system will works, the flow will be works. Okay, try to understand from here. So I have implemented the complete code. So the flow need to be like, yeah, I'm taking the one of the PDF. Let's see. So here we need to import all the dependencies. They're very, very, very important. So the step need to be, you just need to take the whatever the dependencies are required. That's very important. Okay. So the Hugging Face is the one of the uh, company which is providing the required different models, AI models it will provide. Okay. And already it will make the connection between the LangChain and the Ollama. So this is the make the orchestral connection, and the LangChain community will provide the different methodologies and the libraries to make the different operations. So here we are using the chunking operation. So it will again provided from here. Okay. And here I'm installing the PyPDF. This is the PyPDF will useful to load the PDF files and extract the text from here. Okay, the sentence transformer again to run the models from the Hugging Face. Here we are using the one of the embedding model. So embedding model I have taken from the Hugging Face and running by using sentence transformer. This is the Chroma is the one of the vector store. So we have the different vector stores of the vector databases, but here I'm using the free resource. So this is the one of the vector database. Okay. And also I'm installing the only the Ollama. Okay. So after installing all these things, the next step is like you just need to import all the required libraries. And particularly in this project, what I did is So wherever the libraries are required, I'm trying to import from there itself. Okay. So here I have imported the PyPDF. So this is the PyPDF, and from Langchain community I have imported the PyPDF loader. So to load the documents, and after loading that I'm extracting you need all information from the particular PDF, and you need to make the splitting of the all the text. Okay, the splittings is very important, right? So that's why here I'm giving the chunk size and chunk overlap here, trying to understand what exactly is the meaning of the chunk size with the 10,000. Okay, so 10,000 means it's with 200 chunk overlap, right? So here the recursive character text splitter, and here you are uploading the PDF. So the PDF will be sending to the recursive character text splitter. What exactly it does? So it will extract the complete text, and now the complete text will be divided into different parts. The partition will be based on this chunk size. So how many chunks need to this? So you can directly call it as the each chunk like a document. This is the another chunk. This is also another chunk. Okay. These chunks will be happen, and each chunk have the 10,000 tokens. That is main, the meaning of this 10,000 is the particular chunk have the, each chunk have the, so this is a chunk, and the chunk 1, 2, and the 3. So each chunk have the, so 10,000 tokens in there. You can decide based on your requirement and the size of the document. Okay. So here I have given like this. And what exactly the meaning of this chunk overlap? Here what happen is we need to maintain the connection between the each chunk. Okay. So we need to maintain the each chunk. So that's why what we do is, so we need to maintain the at least 200 common tokens between this chunk to this chunk. Again, this chunk to this chunk, 200 common um, whatever the tokens are there. So the tokens, we will maintain the connection, like try to understand the connection between the different chunks. Then only while making the retrieval, that's very easy for the LLM to bring out the proper context. Okay, so that's why we are using this. We have taken. So that is the reason. So here the standard way of giving is we can mention the chunk size. It's nearly, sometimes it will change, but no need to take this much. Sometimes you can mention so 1,000 or 2,000, and the 200 is the chunking overlap, then it will works really quite accurately. Okay, so here what I'm doing is I will take the path of one of my PDF document. So the PDF document I have taken from my local. So I have take the path and uploading here. My PDF loader will take this path, and from this here it will take this is the rag, one of the PDF actually. So this is the PDF, and this is one of the research paper on the array. So I'm uploading here. So the recursive character text splitter will useful to make the chunks. So the chunk size, whatever the chunk size I have mentioned. So the chunk size will do the, so this is the chunk size and chunk overlap coming to here. And it will make the all the splittings of the complete whatever the documents we are considering, it will split. And if you trying to understand what exactly the fourth the whatever the fourth document have, you can see this is the content we have. For you can use the 5 and 6. So, and if you print all the text, it will print in this manner with the metadata along with the each and everything, how it is exactly storing inside the, and how it is exactly splitting like each and every document. So this is the page content we have along with the text. This is the complete one particular chunk have. So if you check, this is the one of the chunk with nearly 10,000 tokens along with the 200 overlap. Okay, so these all are the document. So these all are the chunks. If you check the what is the size of the particular chunks, they are divided into 19 chunks totally. Okay, the length of the chunks. Okay, now I'm importing the embeddings. So first of all, I'm importing the Hugging Face embeddings, and this is the one of the model BAAIBG large model. So this is regarding the English model. So I have taken this model, and to run this, I am importing the Hugging Face embedding. So I'm trying to run this model. So here it is running. So now I'm importing the model from the Hugging Face itself. That's why it was showing like Hugging Face embeddings. So let's say if you are using OpenAI embeddings, so here you need to mention OpenAI embeddings. So if you are using Grok, you can use that particular, or if I am using the AWS embeddings, you can mention here AWS embedding. So, and you just need to import the same thing. Okay. Then I'm taking the vector store. So the complete data I have here in the form of text. The text variable have all the chunks. So here I have taken the chroma. So I have already imported the chroma, and now here creating the collection name as the collection and the embeddings. So here I am running this embeddings. So BAI model I am running over here. Of course, I'm creating the persist directory to store the whatever the embeddings are there. So I have converted into vectors, right? I need to store it somewhere. So I have stored it in my local itself. Okay. You can check it over here. So here it is stored in the Chroma LangChain DB. This is the database have the all the complete file in the form of vector database. Okay. So, and also I have given the unique IDs for the each and every document. This is very important. Yes. Okay. Here I have taken the all the text. Okay. So my complete document over here. So the complete text over here. So I'm uploading, and before give it to the vector store. This is my vector store. So if I am giving the text here, this text will, first of all, each and every text I am assigning with the unique IDs. So the universally unique IDs are very important. So from this only, the LLM can easily retrieve the data, okay, and accurately. That's why I have given the unique IDs, and I'm sending the complete UIDs along with the documents also. Okay. So now the vector store will convert the all the complete all the chunks into vector store and save it in the here itself, the Chroma LangChain DB. In that database we have all the things, and you can make the how exactly the context will come. So I'm giving the question like what is rag. So the rag will send it to the similarity sets to the vector store. Then it retrieve the all the particular context from the vector store. So now this is the answer we get. But this is not so clear, right? So that's why, see, you have a lot of things, and the size also very high. I don't want this much size and this much uncertainty. So it will bring all the similar type of context, but I don't want in this way. So for that, what I do is, So I'm importing the model LLM here. The chat Ollama is I have imported from the LangChain Ollama. So I have given the model. So Gamma 3.1 billion model. Okay, this is the model I have pulled in the initial part. So here I'm creating the chain. So for that, I have given the creating the chart prompt template and whatever the output, what is the way the LLM need to give the output. I need the string output only. Okay. And I'm using this runnable pass through also to get the to run all the prompt properly. Okay. Here, of course, this is again repeated. Just I'm deleting here. So what is the prompt I have given here is the system from like you're an helpful assistant and the answers are based on the provided context. The context is this is my context. This is the complete my context. Okay, this is the context I have gotten. So this context means if you go back to our flow diagram, this diagram, this place we are now. Now we have all the context. Now we are creating the prompts and the chains and we are sending the complete thing to the LLM. Now we get the response. This is where now we are at. We are okay. See here I have importing the library along with the loading the model also. Here I have created the answer how it need to be. The answer of the question based on only the following context. I have taken the complete context over there and I am trying to give it over here and based on the question also. So what are the context and the question I need to uh, send this prompt to my particular LLM. Okay. See, for that, I have created the retriever. So vector stored as retriever will, what it does is it will bring the context. Okay. The context, whatever the context I have, this is where I got all the context. Okay. The whatever the context, I just need to sending to the format documents, the form of. And here the prompt already I have given in the top. This is the prompt. It will take the context as well as the question, whatever the question asked by the user. It will take both and the string output parser. So I have created the complete chain and I am giving the vectors and as well as the prompt and LLM. The LLM will take all these things and based on the given the chain format it will clearly will give the output. Let's see if I ask the same question over here. What is meant by the drag? To run that complete chain, I just need to use the chain dot invoke. So this chain dot invoke will take the what is meant by rag. This rag. So this is the question, right? So this is the question. We'll send it to here. This is where. So run will pass through. So again, it will send it to prompt and this string output parser. All these things will send it to the LLM. Okay. Now LLM will look into the whatever the inputs are coming to this chain and based on that it will give you the response. The same. So here I'm asking the another query. The query like so see here how RAG works, how exactly the RAG works. So here it will explain the how exactly the RAG works, right? So let me rub all these things. Yes. So for this, it is giving the how exactly the data sources it is taken and the chunkings will be happening and the retrieval will be happening and the re-ranking and the feedback loop. So based on the given document, it is explaining so clearly. This is the way you can ask a lot of questions here and you will get the answers. So we can easily this is the way we can ask the different questions and we can make the queries regarding the your documents and we can uh, And ultimately you can run all these things in your local system only. No need of the any API keys, no need of not to purchase anything. You just need Ollama. You need just need to install the Ollama, and based on that you can ask the all the queries. So that's it. So this is the main thing. So first we are uploading the document and the converting into chunks. Recursive character splitter will make all the chunkings. So here embedding model will be a model will make the embeddings, creating all the embeddings for all the chunks and store it in the vector database. So to make the retrieval so clear, like so we can make the vector stores. And if the user asking some questions, and it will again convert into embeddings and send it to the here it will find the similarity search and bring the relevant context, and the relevant context along with the prompt and the query, user query will send it to the LLM. The LLM will understand the whatever the way the output need to generate, that is the way it will the response will generate to the user. This is the way the rack system will work, and you can create a lot of applications for your, let's say if you want to generate the similar how generally you thinking about writing your own system. You can upload those documents, and you can ask the queries. If you want to ask some questions regarding the particular long PDF, you can ask the queries and it will respond. Okay, this is the way you can create and your own applications, and you can make the queries. Thank you. Thank you so much. Bye bye. We will connect again.